Hello, Algebra kids. Welcome back to the channel. All right, we are doing Chapter 7. Although it looks like Chapter 1, we are not in Chapter 1. Let's fix that. We are in Chapter 7, so we're going to cruise through the extra credit review here. And hopefully you guys have a good understanding here on what's going on. If we say simplify, that is telling you that you have a power here that's negative and you cannot have that. No siree. So we need to move it to the bottom. Remember, view everything like a fraction. So we're going to move this to the bottom and nothing changes but that power. Now that power is a positive. So now, because it's a small power, we can do the multiplication here. So 3 raised to the second power, same as 3 times 3, which is 1/9. All right, number 2. It looks like we have a similar situation as up here, except this was a value and this is a variable. So we're going to still do the same thing and move it downstairs to the denominator, but now I have to substitute. And remember, whenever you substitute a negative value, what should you always remember? Yes, put it in parentheses so that you don't make a mistake with that negative. So 1 over that will be 1 over -6 times a -6 is 36. Okay, number 3. Remember, when you see numbers and variables, they're all, although this is a monomial, it's one term. In that one term, there's a multiplication here between them. So it's 8 times 8 to the 0. While anything to the 0 power is equal to the number 1. So it's 8 times 1, which is 8. Number 4, 100,000 as a power of 10. So 10 to some power. That's what a power of 10 means. And you're basically moving the decimal till you get to the number 1. So 1, 2, 3, 4, and finally 5. 10 to the 5th. When it's a positive, when it's a value bigger than 1, you always just count the zeros. If it was a decimal, like let me show you, like 0.0001, it's not the number of ones anymore because you have to move, and that's 3, but you have to pop over to this side. So this one would be 10 to the negative of, again, 4. So it's always different with the number. But if you just remember, you're moving until you get in front of the 1. That's what you have. Small, it's a negative. If it's large, it's positive. Number 5, in 2000, the population of Forest, Virginia was about 8,000 people. Write that as scientific notation. So this is power of 10. Scientific notation is when you have something times 10 to the something, where you're filling in the number in the front and you're filling in the power. So 8,000 people, so you shift again till you have one digit. 1, 2, 3. So it's 8, and it's a power of positive 3. Good. Now, write this in standard form. So in other words, we're going the other way. So this is scientific notation, and this was standard. So we're taking this and going to standard. The only difference is this was a positive because this was a big number. This is a negative, so it tells you you're going to have a very small number. So you're going to have the 5, and the decimal, again, is right here. It's always after the number, even though they don't show it, and it's 4 spots, but it's getting smaller. So it's 1, 2, 3, and 4. 1, 2, 3. So it ends up to be 0.0005. So the number of zeros is 3, even though the power is 4, because of that hop over the 5. Number 7, same base. When they have the same base and you are multiplying them, you can add the exponents. So it's 5, and then you add the 2 plus the 3. So it's 5 to the 5th. And you can leave that one. You don't have to do that since you don't have a calculator. Okay. If it was 5 to the 2 times 4 to the 3, you can't simplify those. You could do them separately and do 5 to the second is 25, and 4 to the third is 4 times 4, which is 16 times 4, which is 64, and then multiply them out longhand. But my point of this chapter is being able to recognize when you do have the same base, because you can simplify it by adding those powers. You cannot do it when the bases are different, like this. You can't combine those. Now, the difference here is you have a base of 4, but the power is 3, and it's raised to another power of 2, so it's a power raised to another power. And in that case, instead of adding like you do here, we're multiplying those. So it's going to be 4 to the 6th, because we multiply the 3 and the 2. When you get to number 9, and you have a power, again, it is outside, like this one is, but there was only one thing, it was the 4. That was being raised to a power. In here we have two things. We have the 2 and the a. So we have the 2, and the power of the 2 is a 1. So both of those have to get power to a power, power to a power. So you got to multiply them both. So it'd be 2 to the 1 times 5 is 5, and a to the 3 times 5, which is 15. So 2 to the 5, 2 times 2 times 2 times 2 times 2. 4, 8, 16, 32. Because 2 is a small number, you can actually figure those out when it gets too big. So at least try it. If it's too big, then, or you can ask me to, and I'll let you know if you need to do it. And a to the 15th. So the caution there is to make sure you don't just do the a. Don't forget about the 2. Up here we only had 1. That's why we only had to do it once. Number 10. In 2000, the population of Geneseo, New York, was about 7,600 people. The population of the entire state of New York was about this many times larger. So times, again, is multiplied than that population. So what was the population in 2000? Write your answer in scientific notation. So first, let's take this 7,600 and write that in scientific notation. Okay, the decimals here, 1, 2, 3. So this would be 7.6 times 10 to the third. And then we're going to multiply it by this, times 2.5 times 10 to the third. We're multiplying these. We don't really need these parentheses here, but the truth is everything's being multiplied, so we can do it in any order. So we're going to do the numbers times each other first. Two spots. So it's 19. The reason is because then I want to put these together because they again have that same base of 10. So I can add those exponents. So I can say, okay, that's times 10 to the 3 plus 3 is 6. Problem is that's not in proper scientific notation, correct? Because I have the 19. So I have to shift this decimal over 1. So that number went from 19 to 1.9. So that got smaller. So this one is going to get bigger. That's right. All right. First one down, first page down. Time for a commercial break. Today, this segment is being sponsored by I said Harvey, but it's not Harvey. Harney and Sons Fine Teas. I do appreciate the peaches and ginger taste. Peach is always a very good taste to enjoy. You can find this located at Walmart in the coffee aisle. It's a very calming drink. If you notice, it does. Let's focus in. Have caffeine. So make sure not to enjoy this right before mom and dad tell you to go to bed. All right? All right. Back up here. next, in the next commercial break, I am going to share the movie to choose for tonight's movie night. All right, but I'll hold you in suspense on that for a moment as we move on to page 2. And now it all looks blurry. Let's get that in focus. Okay, so page 2. We've got 8 to the 16th over 8 to the 4th. Again, you're always looking at that base to see, and it is the same. They're both A's. So remember, when you're dividing, it's like you're subtracting. So it's 16 minus 4, so that's 8 to the 12th. Sometimes we also, for those of you that were having a little trouble remembering, remember we talked about, okay, there's really 16 of those A's up there, and there's 4 of the A's in the bottom. So these cancel off to give you 1, these cancel off to give you 1, these and these. So what you're left with is all those other ones. So 4 of them canceled off. That's why you subtract them and get the 12. Okay, and the next one, we do have the fraction in here, the division, but we have the power of 2, and remember it has to, just like on, let me grab that other sheet for a moment. Just like in here, when we were talking about this, there was 2 things that got raised to the 5th power. Well, similar thing here, except that there's the 4, there's the y, and there's an x. So in this case, there's 3 things that all get raised to the 2nd power. So don't forget that 4 has a power of 1. And it might help you to actually write that in so you don't forget. So now I'm multiplying because it's a power raised to a power. So 1 times 2 is 4 to the 2 times y. 6 times 2 is 12. 3 times 2 is 6. So 4 to the 2nd power is 16. The rest I'm just rewriting. We're done. Okay, here we go again. What's different from up here to down here is this power is negative. So you got to handle that first by doing the reciprocal. So I'm going to do b to the 5th over 2. I didn't change anything else. Nothing changed except I took the negative off and made it a positive. Okay, now we look inside. How many things will I raise to the 3rd power? This one and this one. There's 2 items. So b to the 5 to the 3. 5 times 3 is 15. Remember, the power of the 2 is a 1, so put it there. Whoops. So 1 times 3 is 2 to the 3rd. 1 times 3. That's small, so we can write it out. 2 to the 3 is 2 times 2, which is 4, times 2, which is 8. Simplify the quotient. Quotient means to divide. So write it like that. Write the top over the bottom. Okay, put the top one, 6.4 times 10 to the 9th, and then write the bottom one, 1.6 times 10 to the negative 3. Again, we're going to want to put these together, work with those together, because the base is 10, so I can deal with these. But then first I'm going to just divide this out. 6.4, the top one's on the inside, divided by 1.6. This actually isn't as hard as it looks. Shift the decimal over 1 spot on both, so my decimal's right there. Then 16 into 64, well, 2 16s is 32. 40, let's see here, 16 times 4 is what? 64, yay! So it actually comes out even to 64. I mean to 4. So this is 4 times, now we got to deal with this. Remember the top minus the bottom, because it's a little tricky because of this negative. So what is 9 minus a negative 3? 12. Be careful with that. If it was a positive 3, if it was a 9 and a positive 3, I would have had 6 here. Because 9 minus 3 is 6. But it's not minus 3, it's minus a negative 3. So be careful on that. And it is in scientific form because there's only one spot here, so we're all good. All right, back to these. When you see that 1/2, do not freak out. Remember, the bottom number is your root, the top number is your power. So the power is 1, so that's not going to affect anything, but the root is 2. So remember, the square root of 36 that is the same as if I had a little 2 there. We just don't write it in there for a square root. We usually just write it like that, square root of 36. No x. Looks like I'm putting an x there now. Let's just get that handy dandy white out. There we go. So square root of 36, and then it's raised to the first power, which again doesn't change anything. So 6 to the 1 is just 6. Now in the next one we do get something in both. We get a power of 3 and a root of 2. So I go again, here's my root. Remember, I don't have to write the 2 there. But the whole thing is raised to this power of 3. That's still up there. But I want to try to do the root first. You can do them in either order, but by doing the root first, it makes it smaller first before it makes it bigger. Otherwise, you make it bigger and then smaller. So, and can be more difficult. So, square root 25 is 5 raised to the third power. So 5 times 5 is 25 times 5 is 125. 17 looks like a mess. Not that bad when you separate it like this. View this. See, these are so close to each other. Not sure why they have to do that. I did not do that. And we have in here a power of a third times a power of 3. Power to a power. Well, what is a third of 3? 1. A third of 3 is 1. 3 times a third, 1. 5 times a fifth, 1. 7 times a seventh, 1. And here we go again. Now the root is 5, but we can also look at it this way, power divided by the root. If you want, you can rewrite that as y to the 5th power over the root of 5. And what do you notice? It's 1. Power divided by the root is 1. So my answer is just xy, all that to say xy. Number 18, which polynomial has a leading coefficient of 1? Remember, leading means the highest power term. So let's just find all of them so we can see. The power of the y here is 1. There's no y in here. Power of this one is 2. So this plus 5 is considered the leading coefficient. It's with the highest y power. So this one, the highest power is the x to the third. So the leading coefficient is what's right before it. The highest power in here is x to the third. So what's in front of it is a positive 1, which is what they asked you for. That's my answer. But I wanted to show you something. Here the highest power is y to the second. The coefficient in front of it is a negative 1. So be careful. That was really close. So you're looking again for that power. That's what tells you, because if you were going to rewrite this, it would be 2x to the third plus 1. If you were going to rewrite this, it'd be negative y squared plus 5y minus 4. And remember that leading coefficient is always in front of that highest term, so it would be a negative 1. It would be a 2. If you rewrote this, it would be 5y squared plus y minus 7. If you rewrote this, you'd have x to the third plus 3x squared plus 2x. So the numbers in front don't matter. I'm looking at the powers, and it's 3. Now that I've determined that's my front end here, I figure out what's in front of it, 1. Number 19, classify this according to degree and the number of terms. Okay, so the degree of this is 2. That's the highest degree in there. And that is a quadratic. If it was just the 1, if I took off this and just had that, it would be a linear, because it's just a power of 1. That's on that chart. I can't remember what section that was in, but there's a whole chart. And the number of terms, 1, 2, 3, means that it's a trinomial. Again, if it was like this, it would have been a binomial. Linear binomial too. And if it was only one term like that or like that, that's a monomial. That's one. All right. Great. It's time for our second break, and we're going to now introduce the movie that I recommend. It has a very good lesson. It's Care Bears Helping Hearts. Now, unfortunately, they do not. What is that person that's what? Who is that? Oh, okay. I don't know where this little guy came from. I think he wants to watch the movie. But look at this. Lessons from the heart, helping others. I think you all should watch this. Look at it. It includes 8 stories that you can all learn from. I'm sorry Funshine is not in this one. Funshine is a favorite of all, I know. But again, grab your tea. He's in it. Oh, Funshine is in it. Excuse me, I've been corrected. I apologize. Funshine is in it, so you can all be rest at ease. I don't think this little monkey dude is in it, though. Not sure where he came from. How did he find his way to the solo home? Okay. Onward. Last page. Brett has. Let's get this focused again. 100 feet of fence with which to make a rectangular cage for his dog. The area of the cage is square feet as given by the polynomial. Right here, I circled it because they're giving you all these words, trying to get you to see a real life situation, but they are, but it's not as complicated as it sounds. They're telling you that the W in here is the width of the cage, and they want to know, well, okay, if this means area, because this right here tells you that this is the area, let's write it down, area. Then they say, okay, but the area of the cage, if the width is 8 feet, so they want you to put the 8 in here and see what you get then for that area. So again, don't forget to, when you substitute something in, just throw parentheses around it. It does keep it easier. Because now this is going to be squared, not the negative will stay. And then 400, and the area then is, what is that? What's 400 minus 64? 36. G. Okay, so it really is just about you, and ultimately just substitute the value in there, but they're just trying to put it into the application there. Now we're going to add. We've got a polynomial here and a polynomial, and we're adding them. So this is the situation where you have 1, 2, 3, 4, 5 terms you're talking about. Since you're adding, and there's a positive before this, these parentheses don't really matter. Okay, if that was a minus, they would matter, and we're going to do that one next. But I can just rewrite this without the parentheses. And now you're just looking for like terms. Like terms have the same exact variable combination. So I've got an x to the 5th and an x to the 5th. I got 3 of them here and 2 here, so I'm going to have a 5x to the 5th. Then I'm going to look and see, are there any x to the 3rds? There are not. So I'm going to rewrite it along with the sign in front of it. And then I see that what's left is the minus 4 and the plus 3, which is a minus 1. Done. I'm sick of the pink. How about that? How's that? I'm going to go to the blue. But now we're switching gears to subtraction. Now it does matter, okay? The first parenthesis doesn't really, so I'm going to rewrite that. But this, remember, changes both signs in here. So in this case, we got a positive and a positive, so they're both going to change to a negative. If one of them was a negative, it would change to a positive. It just flips. So this positive becomes a minus 5a squared, and this becomes a minus 3. Make sure you don't just do it to the first one, but to both. Now, let's look for like terms. A squared, we've got 2 like terms there, a positive 7 and a negative 5. That leaves us with 2a squared. I don't see any other a terms, so I'm going to rewrite that but again we have a plus 6 and a minus 3. Those are like terms. So we have a plus 3. Okay, we went from adding, now we're subtracting, and now we're going to multiply. Multiplying is actually is not bad because remember you can multiply in any order. There's no adding or subtracting in here. We are going to multiply over here. There's a multiplication in here where there's adding and subtracting inside, and that's a little more complicated, but here there's no adding and subtracting. So we can just literally decide, oh, okay, I'm going to take the 8 and the 4 and the 2, and I'm going to multiply those all together first. And I'm going to sneeze, hang on. Okay. 8 times 4 is 32, times 2 is 64. Now I look over here. We got an r to the first. I'm looking for other r's, and an r to the sixth. So when I have an r to the first times an r to the sixth, I add the exponents and get r to the seventh. Now I'm going to look at my s's. I got an s to the second. I have an s to the third, and another s to the third. So I've got, add them all up, 5, 8. And that's that. Up here, we got a rectangle. As soon as you see a picture, just draw yourself a little picture too. So the width is W, right here. Width is W. And the length is 5 less than the width, which they give you then right here. 5, that's 5 less than the width. Write a polynomial for the area. So area, remember, is the width times the length. So what is the width? The width is just the letter W. So I'm going to put W back in. But the length, put it in parentheses, because of the subtraction, is W minus 5. So when they say write a polynomial, they want you to multiply this out and use your distributive property in the spider legs. W times W is W squared, because you're adding the exponents, minus W times 5. And instead of writing W5, we always put the number first usually. So we put 5W. Now we get to the more complicated situation, and that is a little more complicated too, because down here, remember, there was no adding and subtracting, and up here you did have the subtracting, so you needed to distribute and multiply this by both. But now I got two sets of them, where there's a subtracting in here and adding in here, so that's, remember, that FOIL method. It's a 2 by 2, 2 in here, 2 in here. So you do the first terms, x times x is x to the second. You're adding the exponents. The outside, x times 6. And these are all terms, so you're adding or subtracting them all. Inside, negative 2 times x. And last, negative 2 times 6. When you do it in that order, which you don't have to do in that order, but when you do it, the outside and the inside are always going to be like terms. So you've got the positive 6x and the negative 2x, which is going to be a positive 4x. So you combine those. Remember, you cannot put an x squared and an x together. Those aren't like terms when you're adding. You cannot put an x and a 12 together. Those are not like terms. When you are adding and subtracting, you can only put things together that have the exact same variable combination. The same variable, the same power, and if I had a y here, that's fine, but I couldn't put it with something else unless it was yx squared, the exact same variable combination. Exact same letters. All right, a couple more to go and we're done. All right, so when we look at this, I've got a 2 by 3, so FOIL isn't going to necessarily work. We're going to take the first term, though, right here, and we're going to multiply it by all 3 of the terms in here. So x times x to the second, again, you add the powers, it's x to the third. And then we have x times 4x. So the number gets multiplied, so it's a 4. And then the x times the x, you add the powers, and it's x to the 2. Then we do x times 1. which is 1x or just x. Now we go to the second one. Here we do the same thing with all three. 2 times x squared plus 2x squared. 2 times 4x is plus 8x. 2 times 1 is plus 2. So we should have 2 times 3, 6 terms. 1, 2, 3, 4, 5, 6 terms. Now we got to look for like terms. This is an x to the third power. I don't see any other x to the third powers, so I'm going to rewrite it. 4x to the second. Do I have any other x to the seconds? Yes. So I have a pair of like terms right here. So 4x to the second plus 2x to the second is 6x to the second. Now my next thing is x. Do I have any other x terms? Yes. I've got a plus x and a plus 8x. So remember there's a 1 before it. So 1x plus 8x is 9x. You add the numbers in the front and then the plus 2. X to the third, x to the second, x number. No like terms in there. 27, we're going back to FOIL again. First terms, x times x is x squared. Outside terms, x times a negative 6, negative 6x. Inside, 6 times x. And last, 6 times a negative 6. It's a negative 36. The outside and inside are like terms, so you can combine them. And you get what? What's negative 6 plus 6? 0. So this is your answer. And that is also called a difference of squares, because difference means subtraction. It's subtracting. And squares means when you do the square root, it will come out as a whole, or as a even number, not a fractions. So x to the second, when you do the square root, you just get x. 36, when you do the square root, you get 6. Comes out nice. So, oh wow, I'm off the screen. Sorry about that. So square root of x squared is x, square root of 36 is 6, and it is a difference. Difference means subtraction. So is this a difference of squares? Okay, we'll do the check. Is there a subtraction? Yes. What's the square root of x? Second. Comes out even. Remember, if it's ever an even numbered power, like 2, 4, 6, 8, 10, you can always do the square root of it. If it was 3, 1, 5, 7, you can't. So it wouldn't be a difference of squares if this was an odd number. And square root of 4 is 2. So yes, all the checks work, so my answer is yes. Well done. All right, folks, we'll see you in class. Bye.